Hello everyone, I'm gonna solve a quick question about continuous random variables. Actually, exponential distribution is most related one. I am I am viewing that part because you can pause and turn here to see the question, or I will try to add it to description if I can. A post office has two clerks. Alice enters the post office while two other customers, Bob and Claire, are being served by the two clerks. She is next in line. Assume that the time a clerk spends serving a customer has the exponentially distribution with parameter lambda. What's the probability that Alice is the last of the three customers to be done being served? No integrals are needed, it's an hint. What's the expected total time? Total time Alice needs to spend at the post office. It looks nice, yes. Let's imagine the post office. That's Alice. It looks, yes, okay. That's Alice. There is like tail query. Clerk 1 with parameter lambda, serving time. Clerk 2 with parameter lambda again. It might be hard to take videos like that, but I have to now. Bob is here, assume, doesn't matter, you can interchange them, and Claire is here. Alice, Bob, Claire. Now, firstly, we need to define some parameters to make the question easier. Actually, they are not much necessary for this question, but we might get most complicated one about the QE question in the exam. So let's do that. SA, serving time of Alice by the clerk. SV, serving time of Bob. Serving time of Bob by the clerk again. SC, that's the general view. Serving time of Claire by the clerk. Okay. I want to also define one random variables because of the second part, waiting time of Alice. Okay. Probability that it seems good. Alice is the last. Is equal by LOTP. Actually, total time that Alice spends on the post office is connected with two clerks. The clerk that serves Bob and the clerk that serves Claire. Actually, the serving time is the same, so it doesn't change anything whether clerk or Bob leaves first and which clerk Alice come to being served, but it's important to generalize the problem. So probability that, actually I will start with the given part. Bob leaves first or Claire leaves first affects which clerk Alice is being served. So Bob leaves Actually, I will start with Claire. Claire leaves first means serving time of Bob is greater than serving time of Claire, because Claire leaves first. Then, in this situation, Claire lived first, Alice come to the clerk 2, which Claire is being served. Then Claire gone, Alice and Bob are in 2 clerks. So Bob is also need to leave before the Alice. To be Alice is the last one. So serving time of Alice greater than serving time of Bob. Times, by the definition of LOTP, probability serving time of Bob is greater than serving time of Claire. Plus, again the same thing, probability for the given part. It makes the problem easier, I think. This time, Bob leaves first. Bob is gone. Alice come to the clerk 1, that's which Bob is being served. Alice here, Claire is here. So Claire also leaves second. Firstly, serving time of Claire is greater than serving time of Bob. And Alice, serving time of Alice is greater than serving time of Claire. Why? Alice and Claire is here. Claire needs to leave first, then Alice. Times probability that serving time of Claire is greater than serving time of Bob. I will see the general picture. You can think and pause here. Then, what comes next? Finding these values. It comes by the, I didn't write, but by the property of exponential, which is next type property. Think about that. There's 2 clerks. 2 clerks serves with parameter lambda. Not exponential, sorry. Property of Poisson. Number of servers each clerks did is distributed as Poisson with parameter lambda. So probability that next serving is served by clerk 1